consider m equations in n unknowns. The same notations. That is, first equation I will denote as a11 x1 plus a12 x2 plus dot 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 a1n xn is equal to b1. I will continue the same one. Okay, that is a non-homogeneous. Second equation a22 x1 a21 plus a22 x2 plus a2n xn is equal to b2. So likewise continue. The mth equation is given by am1 x1 plus am2 x2 plus dot 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 amn xn is equal to bm. Okay, and suppose this system of equation is represented as number 1. So already I have discussed, in this equation if you put this constant as a 0, if you put this constant term as a 0, then this system become homogeneous. That part already I discussed. So let b1 is equal to b2 is equal to and so on, bm is equal to 0, all terms 0, then we get system of homogeneous equations. That equations are, first equation is a11 x1 plus a12 x2 plus a1n xn is equal to 0. Okay, second equation a21 x1 plus a22 x2 plus a2n xn is equal to 0. So likewise if you continue the mth equation is given by am1 x1 plus am2 x2 plus dot 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 amn xn is equal to 0. Suppose this system of equation I will represent as a 2. Now if you apply the the same system again, same concept, this is a particular case of non-homogeneous system. We write this system in the matrix form. That is a coefficient matrix multiplied by matrix of unknowns equal to the 0 matrix. Instead of the constant matrix you will have 0 matrix. The unknowns are x1, x2 dot 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 xn. From the first one, what are the coefficients? a11, a12 and so on, a1n equal to 0. Second equation a21, a22, a2n equal to 0. So likewise continue the last row am1, am2 and so on, amn equal to 0. Now this system I will denote as ax equal to 0. 0 means null matrix or 0 matrix. Okay, that is a particular case where a is the coefficient matrix, x is called matrix of unknown, O or capital 0 is called as a null matrix, where A is coefficient matrix. Capital X is matrix of unknowns. And capital O is 0 matrix. Now suppose if you discuss the consistency of these equations, so what is your opinion about the consistency? This equation is a consistent always. What is the rank of A and rank of augmented matrix? Yes. Yes, anyone reply? तुमच्याकडनं आवाज आला तर मला वाटतं की क्लास चालू आहे. What is the consistency? For your understanding, here I will write. Suppose this is a matrix A, this is a matrix X, this is a matrix 0. Okay. So for your understanding, here I will write augmented matrix. Suppose A0, which is given by coefficient matrix A11, A12, A1n, A21, A21, A22, A2n, continue the last one, AM1, AM2, AMN, and you have to attach one more column, and that column is given by 0. That column is given by 0. So let rank of A is equal to R. Then my question is, what is the rank of augmented matrix A0? What is the rank of augmented matrix A0? Look at the matrix, because the last column is identically 0, whether that affects on rank of A0. Quickly. My question is rank of A. Yes, now obviously, this last column is 0 ना, त्याच्यामुळे काय फरक पडणार आहे का? Nothing, because that is a 0 term. So always in this case you are getting rank of A is equal to rank of A0. Rank of A is equal to rank of A0. That means the system of homogeneous equation, this system is always consistent. इथे चेक करायची गरज नाही. Always consistent. Okay, this is a particular case of non-homogeneous equation. It is always consistent. So not necessary to check the consistency part. Okay. Now next one. So here suppose I will assume, let rank of the matrix A is equal to R, and definitely if required you can write rank of A0. Rank of A0. Case 1, again you have to consider the two cases. Case 1, if R is equal to N, recall the case from non-homogeneous system. If R is equal to 1, what is the case? If R is equal to N, then what is the case? Rank is equal to number of unknowns. What is the case in case of a non-homogeneous system?
Unique solution.
Unique solution. Same conclusion. Here also you will get unique solution. But one thing you can observe, 0, 0, 0, 0 is always the solution. That is x1 is equal to x2 is equal to xn is always one of the solution, and this solution is called as a trivial solution. For a system of homogeneous equation, this is always one solution. This is always one solution. So if R is equal to N, in that case you will get only trivial solution. Second case, if R is equal to less than number of unknowns, what is the case in case of a non-homogeneous?
Infinite solution.
The same thing, same technique. Here also you will get infinite solutions, and number of parameters given by same formula. Number of parameters given by n minus r. So if you compare with the system of non-homogeneous, this is a particular case of that. Only thing you have to put right side is equal to 0. Is it clear? Any question? I will continue the example. solve the system of equations. It's a test for consistency because this system having always a solution. That's why it is a consistent. That's why you will have a question of the type solve the system of equation. First equation is x plus y plus x plus y plus 2z equal to 0. Second equation x plus 2y plus 3z equal to 0. Third, x plus 3y plus 4z equal to 0. And one more equation is there, 3x plus 4y plus 7z equal to 0. How many equations are there?
4.
4 equations in 3 unknowns. Same system, same procedure. So first we write these equations in the matrix form. So we can write simultaneously because the same technique. We can write the given equations. There are 4 equations in 3 unknowns. That unknowns are x, y, z equal to 0 matrix. The unknowns are x, y, z. From the first equation, the coefficients are 1, 1, 2, 0. 1, 2, 3, 0. 1, 3, 4, 0. 3, 4, 7, 0. And suppose this system I will denote as Ax equal to 0. This system I will denote as Ax equal to 0. Now same procedure. Consider the augmented matrix. Consider the augmented matrix which is denoted by A comma 0, which is given by a little bit. I will scroll up. Yeah. So which is given by, how to obtain the augmented matrix? Attach one more column, that is 1, 1, 2, 0, 1, 2, 3, 0, 1, 3, 4, 0, 3, 4, 7, 0. So last column is identically 0. That does not affect on the rank. Okay, we follow the same process. That's why I'm writing. So again, you can use a vertical line to make a difference between. Now the procedure is same to reduce this matrix to the echelon form. Now the diagonal entry is 1, 1, 2, 2, 3, 3, 4, 4. Is it right, ma'am? Yeah. So the elements which are below to A11, these elements reduced to 0. Tell me the transformations.
R2 minus R1, R3 minus R1, R4 minus 3R1.
Yes. The transformation is by R2 minus R1, R3 minus R1, and R4 minus 3R1. So the new equivalent matrix where first row no change. 1, 1, 2, and 0. Directly subtraction. 1 minus 1, 0, 2 minus 1, 3 minus 2, and 0. 1 minus 1, 0, 3 minus 1, 4 minus 2, and 0. Now next you have to multiply by 3 and their subtraction. 3 minus 3, 4 minus 3, 7 minus 6, 0 minus 0. Okay, now this one. Now again, this is your diagonal entry. After getting the elements below A11 to 0, these two elements you have to reduce to 0. Tell me transformation. 5.
R3
R3
minus
minus 2
2
R2.
R2.
R4.
R3 minus 2 R2 R4 minus R1.
Correct. R2 is the key row. R4 minus R2. So the new equivalent matrix. So the new equivalent matrix, first row no change. 1, 1, 2, 0, 0, 1, 1, 0. I think you are getting identically 0. You are getting identically 0.
Rank is 2.
Yes, rank is 2. This is separation and this is your diagonal entry. Elements below diagonal all are 0. So this is in the echelon form. So here rank of AI and rank of augmented matrix. First non-zero row, second non-zero row. So here I will write only rank of A, not necessary to write ABA, or if required rank of the augmented matrix A0 is 2, and which is less than number of unknowns. How many unknowns are there?
3.
3.
3. Therefore number of parameters or parameter, one or multiple parameter is equal to n minus r, that is 3 minus 2, 1 parameter. Now here I will write the corresponding equivalent equation. Suppose this one is a number 2 if not written. So from 2 procedure is same. From 2 the corresponding equations are x plus y plus 2z equal to 0. Second, y plus z equal to 0. Suppose this has a small 1, second one has a small 2. Now again the procedure says that you are having a 3 variables. You are having a 3 variables x, y and z. You can consider any one variable as a parameter, but the general practice is z. So let z is equal to t as the parameter. Let z is equal to t as parameter. So the next, you have to reduce the remaining variables also in terms of the parameter. You have to express or you have to reduce. So z is equal to t. From equation 2, from 2, how you can write y? Y is
Minus
equal to z. That means y is equal to minus t. That is the second variable. Y is equal to minus t. Next, from equation 1. From 1, x can be written as minus y and minus 2z. Minus y means plus t because already y is minus. Minus 2 times t, that becomes minus t, right now? So thus the solution, you are having infinite solution again. Thus the solution x is equal to minus t, correct now? Y is equal to minus t and z is equal to t. That is the required solution. So again every time verify the solution whatever you obtain. So for a verification, this part not necessary to write for your understanding. ओके परीक्षेत लिहायची गरज नाही. t is equal to 1 घेतो मी. Then x is equal to -1, y is equal to -1, z is equal to 1. So you can take any parameter. So LHS of the first equation. First equation is LHS of the first equation x plus y plus 2z. बरोबर आहे का सांगा जरा?
Yes, sir.
X is
Yes, sir.
-1, y is -1 plus 2 times 1. That is equal to 0. RHS. We satisfy the equation. Second equation, LHS is equal to, yes, anyone?
Y plus Z is
No. Second equation from the statement.
X plus
X
2y plus
plus
3
2y
z.
plus z.
2y plus 3z. Substitute the value. X is -1, y is -1, it -2 plus 3. Again it becomes 0. Second also satisfied. Next third equation is
X plus
X
3y plus
plus
4z.
plus 3y plus 4z.
that means -1, -3 and plus 4. That also satisfied RHS. And the fourth equation, x
3x plus 4y plus 7z.
7z. That means minus 3, minus 4 and plus 7. Again that is 0. So all the four equations satisfied simultaneously. So here you can conclude whatever solution you obtain, that is the correct. That's why in the examination you can use calculator, not necessary to write. Directly substitute and verify LHS is equal to RHS. If that satisfied, that means your answer is correct. Okay. Second equation, second example. Solve the equations. First one, x plus 2y. X plus 2y plus 3z equal to 0. Second, 2x plus 3y plus z equal to 0. 4x plus 5y plus 4z equal to 0. X plus y minus 2z equal to 0. Now simultaneously solve. Again, four equations in three unknowns. First, write in the matrix form. So we write coefficient matrix into matrix of unknowns equal to 0 matrix, the right side term. Now the unknowns are x, y and z. Unknowns are x, y, z. First equation 1, 2, 3 and 0. Second equation 2, 3, 1 and 0. 4, 5, 4 and 0. 1, 1 minus 2 and 0. And suppose this I will denote as ax equal to 0, suppose. That means where A is the coefficient matrix, X is the matrix of unknown, 0 is the, or capital O is the 0 matrix. Consider the augmented matrix. Consider the augmented matrix A0. So that matrix can be obtained by attaching one more column to the given matrix. That is 1, 2, 3 and 0, 2, 3, 1 and 0, 4, 5, 4 and 0, 1, 1 minus 2 and 0. So this is the separation. Again fix the diagonal entry. This is a diagonal entry. The elements below 2a1 1 you have to reduce to 0. Yes. What are the transformation? Yes, anyone? Why R2 minus 2
minus 2
R1?
R1, R3 minus 4 R1, and R4 minus R1.
R4 minus R1. So the new equivalent matrix, first row no change. 1, 2, 3 and 0. Multiply by 2 and subtraction. 2 minus 2, 0. 3 minus 4. 1 minus 6. Okay. So next you have to multiply by 4 and subtraction. 4 minus 4. 0. 5 minus 8. 4 minus 12.
Minus 8.
Yes, minus 8 and 0. Directly subtraction. Last one 0.
0 minus 1 minus 5 0.
Minus 5. No?
Yes.
Okay. Again, this is your diagonal entry. After getting that elements below a1 1 to 0, these elements. Tell me transformation. By
R4 plus R1.
R3 minus na same sign, that's why 3 times R2, R4 minus R2. R2 is the key row. R2 is the key row. Therefore, new equivalent matrix, that is first two rows remain same, 1, 2, 3, 0, 0, minus 1, minus 5, 0, multiply by 3 and their subtraction, 0 minus 0, minus
0
3
0
minus 3.
7
This one is
7
7,
0.
0, 0, 0, 0, 0. Is it right?
Yes, sir.
Yes, sir.
This is the separation. Now again you can see the elements below diagonal all are 0. So this is the required echelon form. This is the required echelon form. Yes. What is the rank?
3.
3.
So here rank of A is equal to rank of augmented matrix A0 is equal to 3, and that same is equal to number of unknowns. Number of unknowns. What is the conclusion? Is it necessary to solve manually? Therefore, given system has, yes, what is the conclusion? Has
Unique solutions.
Unique solutions.
unique, one more word you have to use here. If that is a unique, then that is a trivial solution. Unique trivial solution. That means x is equal to y is equal to z is equal to 0. So not necessary to solve manually. Not necessary to solve manually. So directly you can conclude that the equation has trivial solution, unique trivial solution. So directly you can write it, or manually if you are using the back substitution, then also you will get the same thing. So I will advise directly write the solution. Okay. The third one. First equation is 4x1 minus x2 plus 2x3 plus x4 is equal to 0. Second equation 2x1 plus 3x2 minus x3 minus 2x4 is equal to 0. Third equation, x1 term is absent, 7x2 minus 4x3 minus 5x4 is equal to 0, and 2x1 11x2 plus 7x3 plus 8x4 is equal to 0. I think 4 equations and 4 unknowns. Try for this. First write in the matrix form. We write in the matrix form. 4 equations in 4 unknowns. The unknowns are x1, x2, x3 and x4. The first equation, the coefficients are 4, minus 1, 2, 1 and 0. Next 2, 3, minus 1, minus 2, 0. What I have to write here? x1 term is absent. 7, minus 4, minus 5, 0. 2, minus 11, 7, 8, 0. And suppose this is denoted as a ax equal to 0. This is number 1. Consider the augmented matrix. consider the matrix A0, which is given by, you have to attach one more column. First row, 4, minus 1, 2, 1 and 0. 2, 3, minus 1, minus 2, 0. 0, 7, minus 4, minus 5, 0. 2, minus 11, 7, 8 and 0. Can anyone suggest the transformations?
2R2 minus R1.
R1 can be changed to R1, R2.
Okay, interchanging.
Yes, sir. Interchanging first and second row.
So instead of that, if you look, if I multiply second row by 2, my ultimate target is these elements are reduced to 0. Yes. Here I will multiply by 2. Here also I will multiply by 2. It's become 4 and 4 and I will subtract. Is it right now?
Yes, sir.
Yes, sir.
2R2 minus R1. R2 changes to 2R4 minus R1. Second row, no, third row, no change. So the new equivalent matrix. First row, 4, minus 1, 2, 1 and 0. You may continue with your transformation. Answer you will get. So multiply by 2 and their subtraction. 4 minus 4, 0. 6 minus minus. Minus 2 minus 2. Verify the calculation. Something I written wrong. Okay. Minus 4 minus 1. Verify. Third remains same. 0, 7, minus 4, minus 5 and 0. Now once again multiply by 2. Whom you have to multiply by 2? R4 and then subtraction with R1. 0. 11 2s are 22. Minus minus become plus. It's 21. It's 21. Verify.
Yes, sir.
Yes, sir.
Okay. 7 2s are 14 minus 2. 16. 8 2s are 16 minus 1. And this is a 0. Now again, this is your diagonal entry. This is your diagonal entry. Reduce the elements which are below 2A to 2. These by element. Yes, tell me transformation.
R3 minus R2, R4 plus 3R2.
R3 minus R2 and R4 plus na
Plus 3R2.
3R2.
Yes,
So
sir.
change for third and fourth row. First two row no change. That is 4 minus 1, 2, 1 and 0. Second row 0, 7, minus 4, minus 5 and 0. I think the remaining two rows you will get identically 0. Verify.
Yes, sir.
What is the rank?
2.
Rank is 2. Number of unknowns?
4.
Here rank of A is equal to rank of augmented matrix A0 is equal to 2, which is less than number of unknowns. And that unknowns are x1, x2, x3, x4, 4. Therefore, the given system has infinite solution. Given equations or given system has infinite solutions. Infinite solutions. Number of parameters? It is
2.
2.
2.
That is n minus r parameters. That is 4 minus 2. That is 2. Okay. And suppose this equation is number 2. From equation 2, I will write the corresponding equivalent equations and the parameter. From 2, the corresponding equivalent equations for x1, variables are x1, x2, minus x2 plus 2x3 plus x4 equal to 0. Suppose that as number 1. Second equation, 7x2 minus 4x3 minus 5x4 is equal to 0, and suppose this as number 2. So let x3 is equal to t and x4 is equal to s. Why I am taking the two variables as a parameter? We have obtained. Okay, that's why I am taking x3 and x4 as a parameter. As parameters. Now the remaining two variables, x1 and x2, you have to also obtain in terms of the parameters. From small 2, 7x2 is equal to 4x3 plus 5x4. This implies x2 is equal to, divide both sides, I will divide by 7, and simultaneously I will substitute the parameter 4x3, that is 4 times t plus 5 times s. Okay, that is the x2. This is x3, this is x4, this is x2. From equation 1, from 1, 4 times x1 is equal to x2, I will transfer to the right, that becomes minus, become plus. So the next one is a minus. Next one is a minus 2x3 minus x4. I will substitute the parameter. X2 is 4t plus 5s divided by 7 minus 2 times x3 is t minus x4 is s. So here I will take LCM as a 7. Okay, simplifying 4t plus 5s minus 14, बरोबर ना? Minus 7 times s. That is divided by 7. If we collect the t terms, 4t and minus 14, what is the value?
minus 10.
Similarly, yes, 5s and minus 7s.
Minus 2.
Yeah. This is the value for 4x1, but I want to find x1. Therefore, x1 is equal to minus 10t minus 2s divided by 28.
28.
So further, you can take 2 as a common and you can cancel that 2. That becomes minus 5t minus s divided by 14. That is the solution. Okay, thus finally once again I will write all together. Thus x1 is equal to minus 5t minus s divided by 14. x2 is equal to, what is that, 4t plus 5s divided by 7. x3 is equal to t, x4 is equal to s. That is the final answer. So again you can verify the answer if required. You can verify your answer. Okay. So next I will consider an example involving parameter lambda. This is almost end for the topic. This is almost end. Suppose the fourth example. Determine the value of lambda. Determine the value of lambda for which the following set of equations possesses a non-trivial, means infinite case, a non-trivial solution, that means rank is less than number of unknowns, and obtain these solutions for a real value of lambda. Now the equations are, first equation 3x plus y minus lambda times z is equal to 0. Second equation 4x minus 2y minus 3z equal to 0. 2 lambda x plus 4y plus lambda times z is equal to 0. Okay. In the same manner, an alternative method I will explain. So the first I will write the given equation in the matrix form. We write in the matrix form, first coefficient matrix multiplied by matrix of unknowns equal to 0 matrix. Unknowns are x, y, z. First row 3, 1 minus lambda 0. Right? 4 minus 2 minus 3 and 0. 2 lambda 4 and lambda equal to 0. And this system I will denote as a ax equal to 0, suppose. This is number 1. So don't write anybody. कोणीही लिहू नका, पुढचं पाठ जरा लक्ष द्या, थोडं हे इथं अवघड पाठ आहे. So these calculations or that explanation here I will write. Okay. So for examination not necessary to write. Don't write, first listen. So what you have to discuss here? You have to find the value of lambda such that the given equations have a non-trivial solution. If the given equations have a non-trivial solution, then what you can say about the rank of the matrix A? किती असायला पाहिजे? Because A is a, see, first one, A is a 3 by 3 matrix, so possible values of rank is either 1 or 2 or 3. These are the possible values. But the given system has a non-trivial, that means infinite case. The given system has non-trivial, infinite. In that case, what are the possible values of rank? Anyone?
It must be 1 or 2.
Yes, obviously it will be 1 or 2. Is it clear? It will be 1 or 2. प्रत्येकाला लक्षात आला, कारण रँक 3 असेल तर त्याला ट्रिवियल सोल्युशन मिळतोय, पण ट्रिवियल सोल्युशन नकोय. ओके, if rank is equal to 3, then we get trivial solution. But we have to discuss the case for non-trivial, somewhere here written non-trivial. So that's why rank is 1 or 2. Now recall the definition of rank. An integer R is called rank of the matrix if there exists a minor of order R, which is not equal to 0, and every minor of order greater than R is equal to 0. Suppose the first case, if rank is equal to 1, then what we can say? Minor of order 2 is 0 and minor of order 3 must be 0 by definition. If rank is equal to 2, then minor of order greater than 2, that means 3 equal to 0. Now if we consider these two cases, in both the cases minor of order 3 is equal to 0. And what is the minor of order 3 for the given matrix? Minor of order 3 means you have to select all the 3 rows, all the 3 columns. If you select all the 3 rows and 3 columns, you will get a minor of order 3 for a given matrix, and that is
Determinant.
yes, that means determinant. So determinant of A equal to 0. So therefore here for a non-trivial solution, the required mathematical condition is the determinant of A should be 0. So equate the determinant of A to 0, you will get some polynomial in lambda. Okay, I will write the conditions here. Now see, just one thing I want to clear here. So before 10 minutes, 2 to 3 students they asked to admit for the class. So what is the issue? In time, this is almost 11:20 na. So next lecture onwards, after in first 5 minutes only I will admit manually. Okay, latecomers will not allow. Okay, suppose this whatever I explained here, the same thing I will write in the wording. Now here, the system has a non-trivial solution. The system has non-trivial solution if the rank of A, if the same thing I am writing, the rank of A is less than number of unknowns, that unknowns are given as a 3. So for this requires determinant of A is equal to 0, that is determinant 3 1 minus lambda, 4 minus 2 minus 3, 2 lambda, 4 and lambda, this is equal to 0. So I will give 1 to 2 minutes, find the determinant. Suppose solving this determinant by first row, that is 3 into bracket, Sankta, 3 into bracket minus 2 lambda plus minus 3s are 12, बरोबर का बघा calculations, minus 1 into omit the row and the column where the present 4 lambda plus
6 lambda.
6 lambda.
Correct. Minus lambda into bracket
16 plus 4 lambda.
16 plus 4 lambda. Simplify this. That is
5 lambda square plus lambda is equals to 0.
Okay, I will simplify. Minus 6 lambda plus 36. I think this is minus 10 lambda. These terms can be simplified together. And the last one, minus 16 lambda minus 4 lambda square equal to 0. That is minus 4 lambda square. First I am writing square term. After that, the terms containing lambda, that is minus 6 lambda, 10 lambda, 16 lambda. Get this?
32.
Yes, minus 32 lambda plus 36 equal to 0. So multiplying that whole equation by minus 1 by 4, that becomes lambda square plus 8 lambda minus 9 equal to 0. So here you have to split minus 9 such that their product is minus 9 and sum is plus 8. So what are the factors then? lambda plus 9 and lambda minus 1 equal to 0. This implies lambda is equal to minus 9 and lambda is equal to 1. So here you can write the conclusion. The given system has an infinite or non-trivial solution if lambda is equal to 1 or lambda is equal to minus 9. Now you have to consider case by case. What is the timing of second lecture? Yes, anyone?
10:35.
11:35.
11:35.
Okay. Case number 1 I will discuss. Case number 2 you can complete as a homework. This is the end for the topic. Case number 1. Case number 1. Let lambda is equal to minus 9. Now from 1 the same system can be written as. Now here instead of that I will write a augmented matrix. One step I will write here. Okay, one step I will write and that you can simplify. The augmented matrix in terms of lambda. The augmented matrix A0 can be written as, जरा सांगा मॅट्रिक्स मला दिसत नाही, 3 1 3 1 minus lambda 0, correct ना? 4 minus 2 minus 3 0 2 lambda 4 lambda and 0. This is the augmented matrix. This is the augmented matrix in terms of the lambda. Now case number 1, we can discuss case wise. Case 1. Case 1. So let lambda is equal to minus 9. Then the augmented matrix A0 can be written as, substitute the values, 3 1 minus 9 and 0, 4 minus 2 minus 3 and 0.
Sir, plus 9. Sir, 9, sirf 9.
Just a minute.
Plus.
No, minus 9 na? Here see.
But
No,
sir, but
sir, in
it is
case 1.
minus lambda, so 9.
Oh, okay. This one is plus, correct. This one is plus, yeah. Next one is minus 18, 4 minus 9 and 0. Fatafat, tell me the transformations. What are you going to do? I will perform R1 minus R2. Okay. I will try to obtain this element as a 1 or minus 1 by R1 minus R2. So the new equivalent matrix. 3 minus 4 is minus 1. 1 minus is plus 3. Minus 9 and plus 9 and minus is 12 equal to 0. Now remaining row as it is 4 minus 2 minus 3 0. Minus 18, 4, minus 9 and 0. Okay. Now tell me transformations.
R2 plus 4 R1.
Correct. R2 plus 4 R1 and R3 minus
18.
Yes. By the transformation by R2 plus 4 R1 R3 minus 18 R1. 18 R1. Tell me the resultant. Change for the second and third. First row no change. Minus 1, 3, 12, 0. Yes. Can anyone tell?
Zero 10 45 0.
Correct. 0, 10, 45 and 0. Last one. You have to multiply by 18 and subtraction. 4 minus
50, 63. Minus 63.
किती तो आंसर था?
50.
Yeah.
minus 50.
Minus or plus?
Minus.
Minus 60, minus 60. 0.
Next one.
Minus 63.
Minus 9 minus 12 into 18. It's minus 2 to 5, na? It's minus 2 to 5. Yes. Now the next one. What is the transformation? By R3 plus 5 times R2. So the new equivalent matrix minus 1, 3, 12, 0, 0, 10, 45, 0. What about the last one? It should be 0 because you identified that lambda in such a way. It should be 0, verify. And suppose this is the number 2. So corresponding equivalent equations. Minus x plus 3y plus 12z equal to 0, 10y plus 45z equal to 0, and let z is equal to t as a parameter. Z is equal to t as a parameter. Then find y. Suppose this is a small one, this is a small one, and this is a small 2. From small 2, 10y is equal to minus 45 times t. That is y is equal to minus 45 divided by 10 times t. That is y is equal to, yes, minus 9 by 2. And from equation 1, x is equal to 3y plus 12z. So 3 into minus 9 by 2t plus 12t. That is 3 9s are 27t divided by 2 plus 12t. Simplify, tell me. 24 and is minus 27 means minus 3 by 2t. So the first case, when lambda is equal to, therefore lambda is equal to minus 9, then x is equal to minus 3 by 2t, y is equal to minus 9 by 2t, and z is equal to t. So second case you try as a homework. Okay, try to complete. If required, tomorrow lecture I will discuss that case. Otherwise, I will continue with the new unit, new topic. Okay, it's almost 2 to 3 minutes late. So